Hi, today I'm going to walk you through the pipette technique lab produced by Kansas Corn Stem. Hi, I'm Bill Welch. Today I'm going to walk you through the pipette technique lab produced by Kansas Corn Stem. Now, the purpose of an activity like this is pretty simple. Looking at an object like this, we're looking at a pipetter, okay? And in a lot of the high school labs nowadays, you're going to see this instrument, and it's important that teachers and students know how to use this correctly, okay? So first question, you look at something like that and say, what is this instrument? Where can I find that? And a lot of times you're going to find it in labs that are using small quantities of liquid. And then the clues for how to figure out what this is by looking at the structure of it. Now, I've got one here that you're going to see that actually looks a little different than the one in the picture. And the one we're using comes from mini PCR, and it actually has the same function as what you're seeing there, okay? So, it's obviously going to be called a pipette. And this is a multipipeter. In fact, in other words, it's a variable volumes. And the pipette itself is rated at a certain volume level, okay? So on the tips of these, this one is rated at 20 to 200 microliters. So we can't pipette smaller volumes than that, and we can't pipette larger volumes than that. Most of the time we're using this is for very small quantities, okay? Dealing with molecular biology or electrophoresis and using DNA, etc., okay? So what's unique about this is this pipetter has a scale here and actually tells you what the reading on the pipette is at this point in time. To change that, I am simply going to turn this dial, okay? As I turn the dial, you'll see what happens to the numbers, okay? And the numbers in this case are going down. If I turn it in the opposite direction, the numbers will go up. So that's how I'm going to change the volume of this pipetter when I push down this plunger, okay? So, first step is how are you going to use something like this, okay? And to use something like this, we're going to use a little piece of wax paper. It's essentially parafilm. You could use wax paper, something where the water will not necessarily be absorbed by the substance or the material it's in, okay? The next step, when you're looking at this, is to get a pipette tip. There are certain tips that will fit this micro pipetter, okay? So I've actually set this up at 60 microliters, okay? I'm going to put a pipette tip on this. And now I've got the pipette tip and the plunger is here. Now this is actually designed to be held with either hand. I can do it with either hand. But as I'm holding this with my right hand, my thumb will be able to push down on the plunger. And the plunger is right here, okay? So as I can actually push the plunger down. And when I push it down, there's a stop there. If I could push it down, that's first stop. And we call that the soft stop. The hard stop is if I push it further down. So it goes a little bit further beyond that. So when I use this, when I'm trying to pull liquid out, I want to get 60 microliters of this. I'm only going to go down to what we call the soft stop, that first stop there, okay? So I'm going to go in and get some liquid here, and we're going to start by using some blue. And all I'm doing here is I'm pushing down to the soft stop. I'm putting the tip in the liquid. And I'm going to slowly let that come back up. And I slowly let that come back up, it fills with liquid. I'm not sure if you can tell, but that's the volume of the liquid in there, okay? Now, next step is I need to get this liquid onto this little piece of wax paper. And to do that, I'm simply going to slowly push this down. I don't necessarily want to touch this tip to the surface, because when I do that and I push down the liquid's going to come flying out to the side. So I want to create essentially a bubble there. So I'm going to slowly release this down to the soft stop. And I'm making one bubble. Now see if there's a little, I don't know if you could tell, there's a little tiny amount of liquid left in there, okay? So that's where I go to the hard stop now. I've got that there, I'm going to push to the hard stop, and it pushes the rest of that out. Now I've got nothing in that pipette tip, okay? And that's actually how I could put some drops on there. So let's take a look, and I'll try this again. I'll go over here, I go down to the soft stop, I put it below the liquid level, slowly let it come up. Why am I doing this slowly? Because let me show you here. I'm going to do this fast. When I do this fast, sometimes there's little air bubbles in there. And I don't know if you can see that air bubble. You don't want air bubbles in there. I just want the liquid that I'm looking for. So I'm going to slowly pull this up. I get to 60 microliters. There's no air bubble in there, so I'm pretty confident I've got that volume. I'm going to put another bubble down here. Slowly push down to the first soft stop. And I don't know if you can see, there's a little liquid left in that. I need to get that liquid out. So that's where I'm going to push down to the hard stop, okay? I've got these two liquids, and I've got 60 microliters and 60 microliters. What I could do is try to combine these together by just dragging them together. And that's one of the things they want you to try to practice with these. If I can hold this and move this over there. And look, I've got a combined drop there. Now, if I've got 60 and 60, that should be 120 microliters. So what I'm going to do is I'm going to get rid of my pipette tip and get a new one. And how do I get rid of that pipette tip? It's very simple. This is the pipette expeller. So when I push this down, it's going to essentially push that pipette off. The pipette tip, you don't necessarily want to use it indefinitely because sometimes liquid will get stuck inside that. So I'm going to actually push that pipette plunger down. And if you look here, it's going to push that out. And I've got that, essentially that wasted pipette tip. Now what I'm going to do is I'm going to change my volume from 60 to 120, okay? And to turn it the correct way, I'm going to turn this to 120. And I'm not sure if you're seeing as I'm turning this. There's two ways of doing this. You can turn this dial, or you can actually turn this bulb right here. It's open both ways, whichever is easier for you to do, okay? I just went past 120, so I now have it at 120. 60 and 60, 120. Let's get a new tip and let's see if this works. So in theory, I should be able to get all this liquid in this pipette tip if I've done it correctly, if I'm doing it slowly, and I'm going down to the soft stop. So I push the plunger down to the soft stop. I put it into the liquid, and I'm going to slowly let this liquid come up. And if I do this correctly, I should be able to get all that liquid in there. And I just got a little bubble at the very end there. So my technique's not perfect, okay? So the idea would be to try to see if you can get all that in there without getting that bubble in there, okay? So I went down and pushed out the rest of this with my hard stop, okay? Let's try this again. Go to my soft stop. I'm going to pull this in slowly. If I can pull this in slowly, keeping it below the level. Again, this is a technique. Why am I doing this? Because I want to be able to pipette things very accurately and very precisely. And to do that, it takes some still hands, and you also got to be able to use the tip of the pipette in the liquid in very small quantities, in fact. So as I get to this, you'll notice that towards the end of this, it gets a little harder to try to keep just the liquid in there. And at that point in time, we should have a pipette that's full, okay? So it was much better than the first one. Is it perfect? I don't know if I'd say it's perfect, okay? So I'm going to expel that liquid out. I'm going to get rid of this tip real quick. And that is part of what this lab is about. The lab is about you trying to practice with that pipetter, okay? So we've got the hard stop, the soft stop, and the hard stop that I just showed you. You've got the liquid you're going to play with. When I say play with, you're going to try to pull in samples at different various, and the purpose is change these values. Now don't forget, you can't go below 20 and you don't want to go above 200 on this. This is rated at 20 to 200. So if you're cranking below 20 or cranking above 200, you're possibly ruining this pipette. So you don't want to do that, okay? You'll put the samples down on the wax paper and make sure you're trying to expel all of the liquid with the hard stop once you get all of that out, okay? And then again, a lot of times you're actually pipetting these into small containers. Sometimes it's going to be small containers like this. And this is essentially a micro plate with little wells that hold, I think, 2 mLs of liquid. Sometimes you'll be pipetting into something like that, okay? So today, what you're gonna try to do is you're gonna try to expel samples onto wax paper, and you're gonna try to pull them together like I just showed you here. Once you pull those together, you try to pull those back up. Now, that's a lot of practice. So the whole purpose here is practicing with this so you feel comfortable using it. You know which arm or which hand you can use. It makes it feel more natural for you to use, okay? At that point in time, what you're gonna try to do is you're going to pull those drops together and try to see if you can pull that all the way back up with the new volume and see if that works, okay? Now, how good are you doing? Well, if you noticed me, I had a little trouble on that first one. One of the things we're gonna look at and we're gonna talk about is how accurate are the pipettes and how precise are they? Well, accuracy and precision are two concepts that are used in science all the time, all right? And when we're talking about accuracy, if this is the bullseye, the concept of accuracy is how close you get to the actual value. So if I was taking a shot at this bullseye, and this is the bullseye in the middle, and if I was able to hit that bullseye with dots like that, I've actually hit the bullseye in the middle a couple times at least there. That means I'm pretty accurate. I'm getting close to what the target is, okay? Precision is a little different. Precision doesn't really have anything to do with the actual target, okay? Precision is how close together your little shots are. So if I threw a dart at this target and I hit the dots like this, those are my dots, and those are my dart throws, okay? Those dart throws are all close together. That means they're precise, they're reproducible, okay? Am I very precise in my measurements? Well, not my measurements in this case, in my throws. Precision is essentially dealing with how close and reproducible those events are. In science, what we do is we want both. We want to hit the target, and we want to hit the target with very close precision, very, very, very small, with great accuracy and precision. We want both of these, okay? So when you're pipetting is the same situation. You want to make sure you have high accuracy and high precision. So let's take a look at this example here. Low accuracy means that we're not hitting the target at all. It could be there, there, there. We'll throw, let's pretend that's one dot. So we've got low accuracy. They're not hitting the target, are they? And are they all close together? They're not. Okay, this would be considered low precision, low accuracy, okay? Low accuracy but high precision would be something like this. You got 4 dots right there, okay? Those dots are all close together, so it's a very precise throws, but it's not at the target, okay? So it's low accuracy, not at the target, but very reproducible, very, very consistent there, okay? Second thing here, the third thing here is high accuracy but low precision, okay? So high accuracy could be dots that aren't too close together, all right, but are pretty close to the middle, but not right on the middle, but they're also not real close to each other. So in other words, low precision, they're a little further apart. They're not as closely clumped as those, but they're also pretty close to the target, okay? So you could actually have a different row of dots there that are close to the target, not right on it, but they're not close together to each other. So that reproducibility versus hitting the target is what you're looking at. Now, high accuracy, high precision is this. Every one of those goes straight into the middle of that target, and you've got your accurate and your precise. And that's the whole goal in science. If you have instruments and techniques that are high accuracy and high precision, you've got good science going on, okay? So the activity that you're going to do is very simple. You're going to take your digital scale, okay, and to determine how accurate and precise you are, you turn on this digital scale, and it should register 0. You're going to put on your piece of wax paper. I find the mass of the wax paper. I don't have to, because really what I want to do is, the density of liquid, of water that we're using here, these are all just colored water. The density is 1, which means if I've got 1 ml of the solution, it should weigh 1 gram, okay? So that premise of density of water, that's what we're going to use. So I would tear out this instrument. Tear out means I put it to 0. So everything on there is 0. When I add mass to this, it's going to actually register what that mass is. Okay? Pretty simple. So in this case, when you look at the slide we've got here, what you're going to need to do is very simple. The goal is to measure out 2 milliliters of sample with a 20 to 200 microliter pipette, which is what we've got here, okay? And you can decide how you want to get to the total. So you measure out your samples. You can't let any of those dots touch, okay? Then you're going to weigh the total sample. And you're going to use the equation below after you've actually collected some data, okay? So we'll do this real quick, and we'll see how well this works. I've got this set at 120. 120, I'll just keep it at that. I'm going to go ahead and go to the soft stop on this, get my liquid pulled into it slowly, pull that liquid up, and now I'm going to slowly put it into a little drop here, and it's going to measure once I'm finished with all this. I want those 2 drops to be together. I do. There we go. There we go. So if you notice, that measures 0.12, which happens to be very, very accurate with the mass of 120 microliters. Okay, not just very accurate; it's right on. Okay, am I good? Oh, I don't know. It looks like the balance is good right now, and so far with just that drop, it looks pretty accurate. Now, what you're going to try to do is you're going to, on one piece of this parafilm or wax paper, you're going to get that 2 mLs on there. So you got to put drops that add up to 2 mLs. You've got to select which series of samples you're going to do. 10 samples of 200 microliters, 20 samples of 100, 16 of 125. You got to have, this is what you're going to try to do. So once you decide, and my suggestion, if you want to time-wise make something go a little faster, if you have 10 samples of 200 microliters or 20 samples of 100 would be pretty easy to do. You would go ahead and pipette those samples on there all at once and get the massive total mass after you've put the 2 milliliters of liquid on there. And that's going to be a mass that you're going to record, okay? And then we're going to look at something with percent error to try to determine how well we did. So you're going to do this activity 10 times. You're going to record your final weight, and I'll show you how that's going to work. Then we're going to analyze those, and then we're going to try to see how accurate we are using a little statistics, okay? And the statistics we're going to use is essentially going to be getting standard deviation, okay? And that standard deviation will actually tell us how close we came to what we expected to get, okay? So let's do this. Real quickly, I need to show you this Excel spreadsheet that might help you out, okay? So what we've got here is a little data table. Trial 1, after you get your 2 mLs on there with your dots, you'll then get the mass, read off that mass, and you'll write that down or type that into a data table like this. It could be on a piece of paper, or it could be an Excel spreadsheet. You type your masses in here. Well, when you type your masses in here, and I'm just going to throw some masses in here, 2.0, let's say 2.1, I'm going to say 1.98. If you notice what I did was that down here I typed in this formula, and the formula is on your PowerPoint. That formula will work. This is calculating standard deviation, okay? And standard deviation is how far off we are from the expected value as far as that goes. And that standard deviation, the larger that is, that means the further off we are. The more samples you got, obviously, the better that standard deviation should go down as far as that goes. So the goal there would obviously be to do if you're doing good, if you're actually doing obtaining good accuracy and precision, you should be able to get some pretty good results there. Let me pull this up real quick, and here we go. Let's see here. All right, so the goal of this very quickly is to actually try to determine, you got 2 things. Practice pipetting. You should be very comfortable using this instrument, Okay, this instrument should be something that if you feel comfortable using it, you're not going beyond the limits of the instrument, you should be fine. And after that, trying to use a little math and a little standard deviation to try to help you figure out, well, am I where I need to be? Do I have high accuracy and high precision? Or am I so far off, I'm not even close to the target, but all my numbers are the same, okay? This is really where we want you to be. All of them real closely together. In fact, this would be ideal. All of your measurements right on the number that we expect, okay? So the next step is, okay, let's say you get your results and your standard deviation's high. What could be the problem? This is why we do science. Are you reading this correctly? Are you pushing this down to the slow stop, et cetera? These are all the questions that we want you to try to ask yourself. If there is a difference in accuracy and precision, see if you can figure out where that's coming from. Is it human error or is it instrument error? If the instrument's off, then that's something we can actually get calibrated, okay? But this is a tool and instrument you'll use in a lot of labs in biology, chemistry, and some other higher level classes, especially when you get to college too. So it's something that would be nice for you to have that skill set too. This will conclude the pipetting activity lab. To see more labs, if you visit the kansascornstem.com website. Thank you.